In previous lecture, we calculated the Landau levels in terms of Landau formalism. We calculated the classical mechanics on the high magnetic field, and then the classical mechanics results is transformed by the quantum mechanical description, and the final result of Landau level is the energy eigenstate is like n plus 1 half h bar omega c plus h bar square kg square. It is in the first term describes the harmonic oscillation, and the second term is the continuous energy along the c direction. And before understanding the physical meaning of Landau level, and more semi-classical, semi-quantum mechanical description is fruitful to understand more easily. And the semi-quantum mechanical description is that Bohr Sommerfeld equations. And here at this time we'll describe the Bohr Sommerfeld equation rather than the Landau equations, and the result is same, but the physical interpretation is more straightforward, rather can be understood easily. And here I will see the Bohr Sommerfeld equation. Bohr Sommerfeld equation on the magnetic field. The Bohr Sommerfeld equation is that path closed integration of the P in the PQ space is that you quantize like n plus gamma 2 pi h bar. Here gamma is the phase vector, and we can choose arbitrarily. And the photon electron, we studied that from classical mechanics. We see that photon electron in a magnetic field, the canonical momentum is transformed like that h bar k minus e over c vector potential. And here we can see that in the q is that generalized coordinate. Here let's denote that the generalized coordinate by the r prime. Then from the Bohr Sommerfeld equation, the closed integration of h bar k minus e over c vector potential dot the r prime. Here the r prime is that in real space, real space, and anyway, and the moment we already talked that in solid state physics we only deal with momentum space or the reciprocal lattice space, but we are familiar with to consider the real space. And here at first we will start the real space calculation. And the electrons motion, we already say that on the high magnetic field, electrons deflected by the Lorentz force, and on the higher magnetic field, the radius decreases more and more. It becomes a circular motion in some points, and we call it is a Landau level. In the real space, in a sample, and the circulation of electrons orbit means that it is a localization of electron, and it means that in classical point of view, then the electrons do not flow along the x direction, and then it means that it becomes an insulator. Here, the R prime is the real space anyway. It is quantized by the n plus gamma 2 pi h bar. And here, and from the Lorentz force, and we know that h bar k minus k0 means that it is the minus E over C R minus R0 cross H. It comes from the H bar K dot. It is the force on the magnetic field. Then minus E over C. V means that R dot cross H. It is a Lorentz force. And we integrate with the time. Then we can write this one. And also in second term, consider the line integration of the vector potential dot dr prime. Then from the curls, it is Stokes theory, and it becomes a surface integration for curl A dot ds. ds means that the surface integration in a Gaussian surface. Then you can say that it is a surface integration of the h dot ds. Yeah, then the first term and second term can be calculated like this, and we inserted in this equation minus E of C line integration, and R cross H dot dr prime minus, and the second term is that E over C, and the vector potential becomes the surface integration H dot ds. It is quantized by n plus gamma 2 pi h bar. And the cross product and the dot product can be exchangeable, and therefore in this case also minus E of C, let's divide in both sides. And then here we can think that it is that h dot cross here we can write that, and r dot h cross dr prime, and also it can be exchangeable like that. It can be write down, and this term and dot product can be exchangeable. dr prime dot r cross h, and also it can be write down dr prime cross r dot h. Then it is that the minus r cross dr prime dot h. Therefore, then here we divide in both sides of E of C. Then here h dot line integration r cross dr prime is that the second term minus surface integration h dot ds is that in the right side 2 pi h bar c of E n plus gamma. Here let's denote that this equation is a star, and here S means that an area of orbit in real space and here if we write down the R has two components. One is that the R components along the magnetic field direction. Magnetic field direction is the g direction, and therefore the R prime, the R vector can be decomposed as the parallel to the magnetic field direction or a perpendicular direction R prime. And here, because cross product case that perpendicular parallel direction of magnetic field is zero because it is parallel with each other. And also in this case, and the RH cross H equal to zero because it is parallel, and we can only think that. And let's consider the first term in the star. First term of the star is that H dot line integration R is decomposed as the R prime, and it is perpendicular direction of the magnetic field, and RH is that the parallel direction with the magnetic field, and the R prime here, R prime is that equal to is that it is H integration R prime cross d R prime. Here, and in real space, electron circulates in some region, and here R means that here it is R prime, or R prime 1, or the R prime can be exchangeable like this. Here, therefore, here dr prime is not parallel to the R prime. Therefore, the R prime cross dr prime is not zero. Therefore, we also consider for the absolute value, and here it is that anyway is the area of the closed orbit. Therefore, it is 2 pi r prime square r h. Here, let's denote that 2 pi r squared by the alpha. Alpha is the real space. Here, let's denote that alpha is the 2 pi r prime square is the area of the r prime orbit in real space. And r prime is the radius of cyclotron orbit, and therefore, and also it is that here this r prime cross dr prime is that r prime multiply 2 pi r prime, and line integration is like this. And also second term is that minus surface integration h dot ds, and also because h is magnetic field static. If we think that static magnetic field it is constant value, therefore h and the area in real space is alpha. Here is alpha. Therefore, from the equation star, we can think that the first term is that alpha h, and here alpha h, and second term also alpha h, and then here we can think that it is 2 pi h by c of e n plus gamma. I'm sorry, here alpha is not 2 pi r square but pi r prime square because it's the area of the r prime orbit, and here it is not 2 pi r square, pi r prime square. Therefore, it is from the first second term. The first term is the 2 alpha. Second term is minus h alpha. Therefore, the equation star is that h alpha because 2 alpha h minus h alpha equal to h alpha, and it is like this. And we call that it is quantized. It is magnetic field. It is magnetic field. It is quantized magnetic flux, and here h means the magnetic field, and alpha is the area of in real space closed cyclotron orbit. Therefore, we can think that if we think that it is cyclotron orbit, it is this kind of Gaussian surface. The Gaussian surface magnetic field is quantized, and it means that the electron motion is quantized. It is a flux quantization. Here, phi is that the magnetic flux. From this Bohr Sommerfeld equations, and the electron motion is quantized. In such a way that the magnetic flux psi is quantized. Magnetic flux phi of h through r prime orbit is quantized. It quantized as well because electron motion is quantized. That magnetic flux along the cyclotron orbit is quantized like that. The quantized magnetic vortex, we call it is magnetic flux quantum, is that 2 pi h bar c over e, or hc over e. Then it is 4.13 times 10 to the minus 7 Gauss centimeter square. We call it as a flux quantum. It means that the magnetic field is quantized in quantum mechanics, and that this is a basic unit of the magnetic field, and the magnetic field is quantized as a magnetic flux quantum. And you should think that for example, in a supernating materials and in a supernator, if we apply magnetic field, the magnetic field is quantized, and we call it as a vortex. Magnetic vortex penetrate into the supernating materials, and then it is macroscopically quantized value of magnetic field. Then here, we already say that there is a relation of the real space and the momentum space, and from previously, we know that it is here it is comes from the Lorentz force, and it is k space. The left hand side is k space, and the right hand side is real space. Therefore, we can think that there is a real space and a momentum space relation. And here, when we think that it is absolute value, it is that and the absolute value r prime minus r prime 0 is that k minus k0. It is there is a factor eta. Factor eta can be write down ch bar over eh, and it is correlation between momentum and real space. Here, when we think that it is the orbital motion, and pi r prime square has the relation eta square pi k square, and pi r prime square, we define that it is alpha. Alpha is the area in real space of it, and it is that eta is the ch bar over eh square, and here let's denote that a is that here alpha is pi r prime square, and for a strong magnetic field, the electron cyclotron orbit, and the radius is r prime, but r prime is that alpha is the area of real space, r prime orbit, and A means that with this real space can be transformed in the momentum space, then the momentum space can be area. We can think that the area of momentum space, it is that pi k square. This can be transformed to the momentum space, and pi k square is the area of a momentum space. And k of it. Therefore, from this relation, and also here, because we know that the alpha is quantized in the above, here, from here, alpha is quantized. When you write down, it is alpha is that 2 pi h bar c over eh, and n plus gamma, the real space orbital motion is quantized. Therefore, momentum space also quantized. It is that the ch bar over eh square alpha is that here, and ch bar and the alpha 2 pi. We can write down 2 pi eh over ch bar. It is n plus gamma, and it is it is the area area of cyclotron orbit in momentum space is quantized. We call it this Ang-Sagat relation. We call it is Ang-Sagat relation. And here, it means the area A is the momentum space closed orbit, and it depends on the energy of the particular constant of energy surface on the value, and here, for example, here gamma equal to 1/2 for a parabolic band. Parabolic band means that a free electron, and then it means that the orbital motion along the r prime is quantized, and here then the decrease of r prime or the increase of r prime is r prime is not a continuous but a quantized, and the orbital motion is quantized. That's the important result. Important result in this high magnetic field electron motion.